therapy. This is geometry problem 3, and there's not a lot of information here. Given the points -3, 1, 3, 3, 4, 0, and -2, 2, what geometric shape do these two points form? So here's what you've got to do. Now, you're not going to be provided on this graph paper, so you're going to have to figure out a way to know this without that. It's not super important that your graph be perfect, but the fact that it's handwritten means you can't even, I'm just going to name my points, you can't trust what you're seeing. Okay, so here are my points. Call that C, that one's B, and -2, -2. Here's going to be my D, okay? So, kind of looks a little bit like maybe a parallelogram, maybe rectangle rhombus, not sure. So here's what you're going to have to do. There are going to be a grand total of 8 calculations. You're going to have to do slope and 4 times, and you're going to have to do distance formula 4 times, all right? So the slope from A to B, A, remember, is -3, 1, and B is 3, 3, all right? Personally, I think that you might have a better time finding slope if you find it based on what it means, which is the change in y over change in x. If you start at 1, so I'm going to look at the y's first. If I start at 1 and end at 3, I went up 2. If I start at -3 and I went to 3, keep in mind -3 is on the left-hand side of 0 and 3 is on the right-hand side, I've gone up 6. So the slope here is 1/3. All right? And I'm going to get rid of this little thing just because I want as little on the page as I can get. Okay, now then, from B to C. Point C is 4, 0. Okay, do it the same way. Okay, super, super easy. If I start at 0 and I end at 3, I went up 3. If I start at 4 and I end at 3, I went down 1. So the slope here is -3. This is really very significant because remember that perpendiculars are opposite reciprocals. And if you've got a slope of 1/3 and then flipped and negated, it's -3. That means that's a right angle right there. That doesn't mean they all are yet, so we're going to do some more calculations. Okay, point D is -2, -2. So if I start at -2, always start with your y's. -2 and end at 0, I've gone up 2. And if I start at -2 for the x's and end at 4, I've gone up 6. That's 2 over 6, which reduces or simplifies to 1/3, which means this slope right here is 1/3. Okay? If it's 1/3, that means that it matches the one directly across from it, which means these two lines are parallel, which means it's looking pretty good. I just need to look and see what AD is, because it could be a trapezoid, not sure. Okay, D to A now. If I start at -2 and end at 1, I went up 3. And if I start on D at -2 again and end at -3, I went down 1. So the slope of this one is -3 right here. All right, so all my slopes are in blue. You can clearly see it. I did it by jumping rather than the formula. I find that I make more errors when I use the formula in just sign errors. I've got opposite reciprocals for every adjacent side, so I've got 4 right angles, which means at a minimum, it could be a rectangle. But the thing is, I don't know if it's a square or not. All right? So it is a parallelogram. It is a rectangle. And we're going to move to the second part, which is figuring out what is the distance. So I'm going to first do the distance of AB. Now here's a hint. Distance formula, it looks like the how many licks does it take to get to the center of a Tootsie Roll Pop owl. If you think about drawing that little guy in with his little eyebrows and his half-closed disinterested eyes, it's a lot easier to draw the distance formula and then to fill it in. So I'm going to put 3, 1. So I put my 2 y's from AB in. And now I'm going to do my x's, which is 3, -3. All right, so 3 minus 1 is 2 squared, plus 3 plus a negative, or minus a negative is plus, so that'd be 6 squared. Okay, so that would be the square root of 4 plus 36, which is the square root of 40. Okay. Not really interested right now in what that is. I know it's slightly over 6, but that's the distance there, okay? Now then, moving into the distance of BC. The distance of BC is going to be, hold on, I gotta get these, using the same little owl, okay? All right, distance of BC, you go from 3 to 0 and 3 to 4. So that would be 3 squared, which is 9. 3 minus 4 is negative 1 squared, which is 1, the square root of 10. Okay, so the adjacent sides are clearly not the same. The square root of 40 and the square root of 10 are not the same. Now I'm going to do the other two just in case. I think we're pretty clear that it's a rectangle but not a square. But sometimes I make math errors, and if I do just one extra problem, I figure that out. So the distance of DC, same thing. How many licks does it take to get to the center of Tootsie Roll Pop? And I plug in 0, negative 2, and 4, negative 2. So that becomes 2 squared, which is 4. And that's 4 plus 2, which is 6 squared, which is 36. So that's the square root of 40, which is awesome because that's the same as the opposite side, which tells me that I did something right. Okay. Now then, the last little part, one more time, the distance of AD. Okay, draw in how many licks does it take to get to the center of a Tootsie Roll Pop. Plug in your X's, plug in your Y's, and so that would be negative 2, 1, and negative 2, negative 3. Negative 2 minus 1 is negative 3, which when you squared it, you get a 9. Negative 2 minus a negative is plus 3, so that's 1 squared, which is 1. That's the square root of 10. Okay, so looking at this, opposite sides are congruent, okay? Opposite slopes are the same, and adjacent sides are perpendicular. That means this is most definitely a rectangle. Okay, so the next question is one that's going to require that you use some of your algebra skills along with your geometry skills to figure out what the shape is or something about the shape. So as long as you just remember distance formula and slope, you pretty much have what you need here. Here is your well, this one's slightly different. Redemption problem. This one has to do with something different. All right, which of the following transformations carries this regular polygon onto itself? So you're looking here, and just how many degrees do you have to rotate this in order for you to have it fall right back onto itself? One critical thing that you're going to have to know is if you rotate something all the way around, how many degrees that is. Okay, and then if it's a regular polygon, how many times it would fall back into itself in a given rotation. So take a look at that, work with it, and your teacher can help you. This one is a little different than the previous problem with this one if you need it. Good luck.